All right, hello everyone. My name is Bilal, and I lead product for model serving here at Databricks. So today's session is all about getting AI into production. How do you take a model and get it into the hands of users? So at Databricks, we do that via model serving. The idea behind model serving is simple. You give us a model, we would give you a production API. You can take that production API and plug it straight into your application. The API you get from model serving is fast with latency in low milliseconds. It can serverlessly scale to support thousands of queries per second. Actually, it can go all the way up to like 200,000 queries per second. And then it can connect to online data store so that you can serve real-time predictions grounded in live context. So today we're going to talk about two things. First, we will see how you can use model serving in practice to power real-time ML applications at scale. And secondly, we'll look at how we are evolving model serving to cover the next wave of agentic and compound AI systems. So we'll start with first looking at how model serving is being used in practice. The best example of that in action is Skyscanner. And today we are very lucky to have them here with us. Please join me in welcoming Michael Evans from Skyscanner. Michael is Director of Engineering at Skyscanner and brings more than 30 years of experience in software development, along with a deep focus on AI and data in recent years. So he will walk us through what it takes to ship and scale AI for a global consumer product. Welcome, Michael.
Right, thank you, Bilal. My name is Michael Evans, and I'm here to share Skyscanner's journey with Mosaic AI Model Serving. So I want to give you some context about Skyscanner. We're a global leader in travel. We operate at scale, as Bilal mentioned, and we serve more than 110 million users each month to plan and book their trips with confidence and ease. We operate in over 30 languages, and our platform connects travelers with flights, hotel, car rental options from over 1,200 travel partners and across 180 countries. So data is at the core of Skyscanner. We've been using data for over 20 years to power the traveler experience and also to support decision-making within the business. And we use machine learning models, I'll show an example later on, to rank and recommend travel options. And in 2024, we launched our in-app AI search. And there should be a video playing, but unfortunately, it's not quite working today. So I'm going to take us back in time to 2018. That's when we first built an in-house model serving capability. And that capability has served us well, but time has moved on and we needed to make some changes. So we started with a proprietary architecture to serve machine learning models and features in production. So the requests would come in, we would enrich these requests with the features. We would log the requests and responses to monitor the data drift and model performance. And we were running this in multiple regions and operating it at scale. So this has been successful. It's helped us to scale and serve multiple different models in production. However, we had optimized for performance, scalability, low cost per each prediction over developer experience. And what we found was our user internal documentation was sparse. Our data science teams found it difficult to work with features and we're having to kind of bake things into the model. And we had platform challenges as well, where a misconfiguration of a model could actually block the deployment of other models. So we didn't have the right isolation within our platform. In recent years, we've been growing our data science team, and this ended up being a blocker to innovation and experimentation, because these challenges presented a higher barrier to performance. So we also were of the opinion that maintaining bespoke infrastructure was no longer a strategic thing that we wanted to do. And commercial offerings had now kind of reached the level where it was appropriate to change. So shifting to a vendor-managed solution allowed us to invest our efforts in travel-specific kind of models and capabilities. And so we want our teams to focus on problems that are unique to Skyscanner, not that we can get off the shelf elsewhere. Additionally, our architecture wasn't keeping pace with the expectations of our data scientists. So we were using GPUs to train our models, but our legacy platform, our proprietary platform, was actually serving the models using CPUs. And so our data scientists wanted to unlock the benefits of GPUs and reduce the number of workarounds. So given these challenges, we made the intentional shift to Mosaic AI Model Serving. And we now serve our models in production using Mosaic AI Model Serving endpoints. We have this deployed in multiple AWS regions to reduce latency for our travelers. All the models are now, they make their way to production via MLflow that's inside Unity Catalog. We had used MLflow for a number of years, but we hadn't deployed the version that was inside Unity Catalog. And we now get lineage between our data and our models. We also make use of Databricks Delta sharing to manage the models across multiple regions, and I'll show a wee bit of that later. And so this gives us a foundation for real-time ML, but I think it also gives us a foundation for future AI opportunities also. So things that went well. Databricks Asset Bundles was something that we adopted, and it's given us a unified development pathway for both our data engineers and our data scientists. Before, our data scientists were not using version control. They were doing things in notebooks, and their models were getting deployed manually. And we've now moved to a world where we've got Git behind our models. We've got a repeatable CI/CD process. We've moved from an artisanal approach to models, model deployments, to more of a kind of like industrialized for speed of deployment. We also have introduced templated projects so that it helps our data scientists get up to speed faster. That was mentioned in a talk yesterday that I saw. So another thing that went well was we had this legacy platform and we were migrating to new platform. We obviously want to minimize the impact on existing services. And so during the migration, we kept the client-side interfaces stable. So most of the models didn't actually need the services didn't need to change. And model owners had to make some tweaks here and there to address some differences in the environments. When we rolled out to production, we dual published to the legacy platform and to the new platform, and then we would kind of divert the traffic to the Databricks model serving to give us confidence in what we were doing. And also our platform team leaned in and helped the various teams across Skyscanner who own these individual models and services. We've now moved to an architecture where each model has a dedicated endpoint. And Databricks helps us by enforcing the schemas and the requests that are coming in. And this actually allowed us, when we were doing the transition from some of the old models or the old environment to the new environment, to catch issues that we had previously gone unnoticed. MLflow, as mentioned, has given, with Unity Catalog, gives us lineage from our data to the model to the endpoint. And the model promotion is now visible within MLflow. We can see from staging into production. And overall, this helps improve accountability, compliance, reproducibility of our models. Our Databricks environment was originally designed for analytical data processing. And the move to model serving means that we need the operational capability in multiple regions globally. Now, Databricks enforces a single Unity Catalog metastore for each region. So we've introduced operational AWS accounts for each region for isolation purposes. We have a dedicated catalog and workspace per region. And we have custom cluster tagging across our environment so we can get cost attribution across our environment as well. We also had to build an orchestration layer to deploy and sync the models across the regions. So they're coming in via Unity catalog, and then we can get them to each of the multiple regions. And this helps keep the model versions consistent in each environment. We've also implemented a routing layer to take the traveler requests to each of the nearest region for the traveler. And lastly, I mentioned earlier that we shared the models in these different regions using delta sharing. Databricks provided the building blocks for this, but we had to implement this ourselves. We did hit some unexpected issues during the rollout, scaling limits. We managed to break delta sharing whenever we renamed some models. So these were kind of things that kind of tripped us up along the way. The schema enforcement quirks were surprising at times as well. And we ended up with close collaboration with the Databricks team based in the US. We're in Europe. And so time zone at times was challenging, but we did get great support, and that feedback loop is really important for Databricks to get to be able to improve the product for everyone. So we had another challenge that we had was with our own teams. We had come from an environment where we owned the entire model serving environment. And that slowed us down at the start, where we were doing a lot of comparisons between the old architecture and the new architecture, and would it actually meet our needs. So this was a bit of a mindset shift, and we eventually kind of were able to kind of get the performance and other expectations that we had to the right levels, and that allowed us to move forward. And now we can focus on what's important for Skyscanner and unique to Skyscanner rather than before. So I'm going to share an example. Flight ranking is one of our most important models at Skyscanner. And yeah, so this is a picture on the left-hand side, and it shows the flight ranking model in production. When you do a search on Skyscanner, you will see, you'll get a response that shows here's the best recommendations that Skyscanner believes satisfy your search. And the actual behind-the-scenes implementation for this is a 2-tower deep neural network. You'll see on the left-hand side, we've got search embeddings, so there's a variety of characteristics about searches that we've built up from past traveler searches. And on the right-hand side, you'll see an itinerary embeddings, and that's been built up from various itineraries that we get from our 1,200 travel partners. We combine these together to produce a relevance score, and then we do re-ranking on the results to make sure that we've got a good variety. I think in the model on the left-hand side, you'll see different airline providers, so we don't give all the same airline results. Now, I think the interesting point on this is the scale. So we've been running this in production now for a number of months. We are serving between 150 million and 180 million predictions per day on top of the Mosaic AI Model Serving. And we're now at a point, we run multiple models in production, not just flights ranking, but we now have 90% of all of our traffic is migrated onto the Mosaic AI Model Serving. This is a quote from one of our data scientists, and it means that Databricks opens up the function, or opens up the opportunity for capabilities that would have been difficult in before. So we're now looking at GPU inference, I mentioned that before. Reuse of embeddings is an opportunity, especially when you come to AI-based applications. So looking ahead, we want to expand into more use cases, and I think I've got this, I think it's my last slide. We want to make production easier for our data science through standard workflows. So previously, getting our models into production was difficult. Adopting Databricks asset bundles, amongst other things, has improved that situation. We want to accelerate the speed to impact through feature embedding reuse. We want to leverage Unity Catalog, leverage feature store capabilities, and support discoverability, reuse, and lastly, we want to prepare the way for AI native use cases, and we're looking at hybrid patterns for combining ML and AI capabilities. So I'm going to hand back to Bilal, and I think he's got some more to share.
Yeah, thank you, Michael. That was a great walkthrough of how Skyscanner has been able to build and scale AI to millions of consumers. All right, so I want to pick from where Michael left. So Michael's team and many others have now been thinking, how do we ship the next wave of AI? And so this next wave of AI combines generative AI with traditional ML to build systems that goes beyond predictions to deliver real-time, personalized conversational experiences. But to really get the value, you have to take these systems from prototype to production. And that's where many teams get hang up. So let's look through some of the key blockers we have been hearing. All right. First, teams are no longer deploying models. They're deploying compound systems. So where you have models that are talking to other models, data stores, and business logic. And this trend is already happening. In fact, 90% of Gen AI adopters on Databricks are now deploying compound systems. But the deployment options hasn't really caught up. You still need one tool for classical AI, another for generative AI, and then yet another for agent AI. Each tool comes with its own learning curve, on interface, and on governance and monitoring setup. And this siloed approach really makes it difficult to deploy these compound systems. And even when teams are able to go and deploy these things, they hit the next challenge, observability and trust. Many teams that we work with are not able to answer questions. How are these systems doing in production? Are they behaving as expected? Are these drifting or hallucinating? And why is that so? Because observability and governance is exponentially harder for these compound AI systems. Because you are monitoring prompts of models, chains, and tools. And that is why only a very small percentage of teams have been able to go beyond proof of concept. And teams that do push through, scale becomes a hurdle. Because this field is moving so fast, infrastructure teams are playing catch up. They have to they're spending a lot of time maintaining these disconnected services and just doing a lot of firefighting, which leaves very little time to enable new use cases. So only 20% of the enterprises have been able to operate AI at scale. All right, and these are some of the challenges we have been focusing on. And so the model serving has really evolved from just a tool for classical AI to be used for building and deploying these compound AI systems. So first, instead of building 3 different platforms for classical AI, generative AI, and agents, we actually invested to evolve model serving to support all type of models within a single interface. And that also includes all type of foundation models, so be it open models, fine-tuned models, or proprietary models. In fact, many of the proprietary models are now natively available on Databricks. Secondly, governance, observability are now fully baked into the product so that you can start using these capabilities from day one. And finally, we have been investing a lot in just improving the raw serving performance, stuff such as auto-scaling, infrastructure, resiliency, so that you can focus on adding value and not on infra ops. So let me show you what that looks like in action. All right, so here's an example of a compound AI system. You open your streaming app. On the top, you see some recommendations. So these recommendations generally are coming from our predictive model, and the way these predictive models generally works is that they looked at your past viewing history and then make some recommendations. So for example, for this user, you can see the previous liked movies, and the model used that and recommended some predictions. So nothing new here, but you could go here and tap on why this. And this actually opens a chatbot where you can see explanations in natural language on why this movie was recommended. So that's the Gen AI layer, natural language explanation grounded in your viewing history. Now you could go and say, what is the playtime? Oops. I'm just going to try again. Right, here you go. I could also say I am in a mood for a comedy. And what's happening really interesting is that the bot is actually using both classical AI and generative AI to come up with recommendations. And you can really think of, this is like it's basically grounding the LLM with the classical AI predictions. And you can even filter it down and say like nothing over than 90 minutes. All right, so this is where we are heading. Personalized conversational experiences where you're combining both predictive AI and generative AI. So now let's look at some of the pieces that are actually powering this. We'll first look at the serving endpoints. So both the serving endpoints live in the model serving UI. So we have this, we have our predictive model here, and then we also have our LLM here. So they both are running on the same environment, same interface, same API, same monitoring and governance setup. So that's how we are solving the fragmentation problem. Like you can use one platform to deploy any models. Now let's go a level deeper into the predictive model. All right, so I'm going to click on it, and I'll open the lineage view, which I love. So you can just click on the model here. It takes you to Unity Catalog. And version 3 is what I've deployed. And then in the lineage view, you can basically see what data sets and notebooks were used to train this model. And it seems like we are using the movie metadata to train this model. But we just ingested a new user-movie interaction data set, and we think we could use that data set to actually improve our model. So let me kick off a retraining pipeline. So I'm going to go to my notebook so that I can use the new data to build a collaborative filtering model. So I'll just run this notebook, and what this notebook will do is it will train a model, and then we'll log that model to a Unity Catalog. And once your model is in Unity Catalog, from there it's just like a couple of steps to deploy the model. So here's my model in Unity Catalog. All right, okay, it's still training, so I'm going to use the old model here. All right, so this is my model in Unity Catalog, and if you want to just serve it, go here, click this button, serve this model, and let's deploy it to a staging endpoint because we don't want to disrupt the production traffic at this point. All right, I'm going to also disable scale to 0, and let's go ahead and create this endpoint. All right, that's all. That's what you have to do. A couple of things, and you have a live API that you can integrate into your application. Now, once you are comfortable with the quality of the model and you want to scale it to like thousands of QPS, again, you just have to do like a couple of steps, and you can have an endpoint that can serverlessly scale to like thousands of queries per second. So you can go here, click Edit, go to Compute Scale Out, and just choose like the concurrency you need. And here I'm choosing a range that goes from 128 concurrency to 1,000 concurrency. At 1,000 concurrency, I should actually get close to like 50,000 queries per second, and you can just go ahead and update your endpoint. Right, I don't want you to be misled by the simplicity. Behind the scene, we actually have built an entirely new inference stack to support this type of like real-time production workloads. But for you, we have made it really, really simple. It's just like a couple of clicks, and you can get an endpoint that can scale to support thousands of queries per second. Right, now let's look at the Gen AI layer. And under the hood, basically, we're using LLMs to generate these natural language explanations. The key thing really I want to show you is that you can swap this LLM with any of the top LLMs available without making any changes in your client application. So let's go back to our serving UI here. And so here's our LLM endpoint. And you can kind of see here that I am actually using a Claude Sonnet. And let's say I want to switch it to Llama. I could just go here, click Edit. And I can just change this thing to, oh, OK, I need the model name. So I'm going to switch here and just grab the model name from here and switch back and just replace this thing with Llama for Maverick, and we'll just do update. That's it. That's what you have to do. So same code, same prompt, same API. You just pick the model that gives you the best quality. Right. Now let's go back to that collaborative filtering model that we have deployed. So one of the cool things about unifying data and AI is that you can actually track metrics across both engineering and business performance. And the way you do that, first, is that you can enable AI Gateway on each endpoint. So AI Gateway is our centralized service that can monitor and govern AI traffic across all your enterprise. So let me show you how it works. So for example, I could just come here to my endpoint, click on Edit AI Gateway. And from this view, I can do a couple of things. I can enable usage tracking. I can turn on payload logging. I could also do things such as AI guardrails and fallbacks. Fallbacks is something which we have recently introduced. Let's say if Claude 3.7 fails because of some reason, it can automatically fall back to Llama 4 or to OpenAI. So you can configure these sort of like routing policies here. And all of the data that's coming through the AI gateway will then get logged into Unity Catalog. So what's next? And that's kind of where the fun part starts. Once you have your data in Unity Catalog, then you can create custom monitoring dashboard that can measure the success of your AI deployments. So here's what I have created for my deployment. So up top, you can see request volume. So here we are tracking how many requests came in, what's the error rate, what's the mean latency I'm getting. Then below, you can look at some of the model quality metrics that I am measuring. And specifically here, I'm looking at some of the metrics that has to do with ranking relevance. And then down here, you can actually tie everything to your business KPIs. So here I'm looking at, is this actually leading to increased clicks? Is it increasing engagement or conversion? And that's really the power of unifying data and AI, because you can have these both business and engineering metrics side by side so that you can measure the impact and not just the accuracy. All right, there's one more thing that I haven't covered, which is memory. So in real-time systems, model serving is not enough. Your models also need to remember. Why? Because users don't come in isolation. They bring history, past actions, preferences. So your system really needs to respond in context. And in compound AI systems, that memory could actually come from a lot of different sources. You need feature store, you need vector search, and you also need agent memory for multi-turn conversations. And this has been a really big challenge for a lot of teams, because memory often lives in a totally different platform than where you are doing model serving. And so you run into a lot of these scaling and synchronization issues. However, one of the cool things about model serving is that it actually is sitting on top of a data platform. So we are able to do a lot of interesting things for you. So for example, we can do automated lookups, which actually I was using in that demo. We can scale these services together. We can unify the auth across both the products. We can govern both data and AI models side by side. And then importantly, we can help you like debug and give you the full end-to-end lineage in one view. And that's really what I think sets model serving apart. Like, it's not just serving, it's like doing inference with memory, governance, and monitoring built in. All right, let's quickly do like a recap with what we just see and what is possible once you unify the data and AI. First, you can run everything in one place. Classical AI, generative AI, agents, all deployed, scaled, and maintained through one environment. Then you can connect your models to your memory so that you can deliver these real-time predictions that are grounded in live context. First, you have built-in then you have built-in governance. From input to output, you can track observability, lineage, and can plot these like business and engineering metrics. And finally, this is already working in practice. Skyscanner and many other enterprises are already using it to serve AI to millions of consumers. So if this excites you, you can head to your Databricks workspace or to our documentation and deploy your first model in minutes. It's very easy to get started with. And if you are evaluating model serving at high scale, reach out to us. We'll love to partner with you to help you get there. Thank you, and we can't wait to see what you create. Thank you.